Welcome to Pre-Calculus. Today we will investigate writing sigma notation to represent arithmetic series. We'll take a look at two series that we write in sigma notation, and then we'll look at two additional examples where we calculate the first and the last terms of a series from sigma notation. Here's our first series. It's 500 plus 501 plus 502 plus 503 plus 504 plus 505 plus 506. Notice the difference between a series and a sequence. A sequence is simply a list of values separated by commas, whereas a series is a list of values that are connected with addition. So ultimately, we're looking for a sum. Now, for me to represent this in sigma notation is really to take the list and to condense it down into a much shorter, more efficient statement. So the way that's going to look is, first of all, I need to determine how many terms I've got in my series. So I just want to list them and number them out. So I'm going to, above them, write 1, 2, 3, 4, 5, and 6. So in this particular series, I've got 6 terms. Now I can start representing that using sigma notation. So the Greek letter sigma, this is the capital version, is equivalent to the English letter S. We use this because the word sum, which is addition, starts with S. So the way I would start is just to indicate how many terms I'm adding up. So I'm starting with the first term, and we're going to call these terms numbers I variables. So it's going to be I equals 1, and that goes on the lower part of the capital sigma. And we're adding up to the 6th term, so I would indicate that on the upper part of the capital sigma. Now I need an explicit formula that will represent this series, kind of thinking of it as a sequence. And so what I want to do is I want to write the explicit formula, and that'll feature there to the right of the sigma. So my explicit formula for this sequence that's related to this series is going to be really starting with the first term. So my a sub 1 is going to be 501. And then my common difference, if I subtract subsequent terms, 502 minus 501, that's 1. And I see that's a common difference. 503 minus 502 is 1, 504 minus 503 is 1, and so forth. My common difference is 1. So I want to fill these into my template. Remember, the template is a sub n equals a sub 1 plus the common difference times n minus 1. Again, I'm filling in a sub 1 and d. So we'll do so. A sub 1 again is 501. Common difference is 1. And then I'll fill in the rest of the formula around those substitutions. So a sub n equals 501 plus 1 times n minus 1. And again, I want to simplify that to give slope-intercept or mx plus b form. So I'll distribute the 1. That's not going to change the n or the minus 1 at all. And then combine my like terms, and I get this explicit formula, n plus 500. And that explicit formula is going to feature to the right of the sigma. And that completes representing this series using sigma notation. One thing that I need to straighten here is this n, which is representing the number of the term in the sequence, needs to match with my index here. So I'm going to change this I to an n. This needs to match. And once I get that in place, I can box it, and that is complete. Let's take a look at a second example. Here I have a series that is 3 plus 6 plus 9 plus 12 plus 15 plus 18. So again, what I want to do if I'm going to convert this over to sigma notation is just number these terms. So it's going to be 1, 2, 3, 4, 5, and 6. So again, I got 6 terms in my series. So I'm going to write the capital sigma, and I'm going to write n equals 1 to 6. Once I've got the sigma set up there on the left, I want to find an explicit formula to plug in to govern how I'm going to create each term in the sequence. So for this one, for my explicit formula, my n sub 1 is going to be 3. And I need to find also my common difference. So n sub 1 is 3. In fact, let me change that real quickly. We're going to call that a sub 1. And my common difference, again, is going to be the subtraction of a term less the previous term. So 6 minus 3 is 3. I want to check to see if that is common. 9 minus 6 is 3. 12 minus 9 is 3. 15 minus 12, 3. 18 minus 15, 3. So my common difference is going to be 3. So now we're ready to plug into our formula. Again, a sub n equals a sub 1 plus d times n minus 1. And again, I'm plugging in the a sub 1 and the common difference. So we've got those marked already. Each of those is 3. My first term is 3 and the common difference is also 3. So then to get my mx plus b form, I'm going to distribute. So a sub n is 3 plus 3n minus 3. And actually I have a cancellation. So a sub n in this case is going to be 3n. And that completes sigma notation to represent this arithmetic series. Let's take a look now at 2 examples where I have a series that's represented already in sigma notation. And what I want to do is use it to calculate the first and the nth terms of the series. So again, just to identify what first and nth terms would mean in the series, that's really the first term and the last term. So I'm going to use this sigma notation. So I see that I'm starting with the index of 3, and it's up to 9. So my first term is going to start by plugging in 3 into my explicit formula 3i plus 6. So this is going to be 3 times 3 plus 6. And then I just need to evaluate. My first term is going to be 3 times 3, which is 9, plus 6. Again, I'll call this a sub 1. A sub 1 for us is going to be 15. To find my last term, I go to the number at the top of the sigma notation. So I'll write here, this is really called the nth term. And I'll just put here, this is the last one in the series. So we'll call this a sub n. And just like we did with our first term, I want to plug in now the number that's on the top of the sigma. So 3 times 9, plugging in 9 for I, plus 6. And again, I just want to calculate out. 3 times 9 is 27, plus the 6. My last term in this series is going to be 33. We'll take a look at one final example. So here I've got a sigma notation from 3, n equals 3 to n equals 11 of 6 minus 3n. One thing I notice here is that that slope is negative. So I'm expecting that the last term is going to be smaller than the first term. Again, we'll know by calculating. So here is my first term. And this is going to be notated as a sub 1. And to calculate it, I'm going to take my explicit formula, 6 minus 3, and then I want to plug in my first n value from the sigma notation. So the n is 3. So that's going to be a sub 1 is 6 minus 3 times 3 is 6 minus 9. My first term is going to be negative 3. Also, I want to calculate the nth term, which is another way of saying what is the last term in the series. I'll notate that as a sub n, which is going to be 6 minus 3. And then I'm going to go to the number, the index at the top of the sigma, that's 11. So my a sub n, my last term in the series, is going to be 6 minus 33. And if I take that difference, that's going to be negative 27. Negative 27. Thank you for joining for this investigation of writing arithmetic series in sigma notation, and then also using sigma notation to calculate first and last terms in series. See you soon.